Hello, everyone. I'm Lee Hongmei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In the previous lessons, we have learned about the concept and composition of network architectures, including the OSI and TCP or IP reference models. In this session, we will study commonly used network protocols. This mini lecture is divided into two main parts: the basic concepts of network protocols, 2. Common network protocols. The teaching objectives of this mini lecture are: 1. To understand the basic concepts of network protocols. 2. To master common network protocols and their applications. Now, let's begin with the first part, the basic concepts of network protocols. From the previous lessons, we understand that network protocols are a set of rules and standards that define how electronic devices communicate over networks. These rules ensure that data can be transmitted effectively and reliably between devices of different types and manufacturers. Network protocols involve multiple layers, each responsible for different communication tasks. So, what are the basic concepts of network protocols? Network protocols are organized using a layered approach, where each layer performs specific functions to ensure orderly network communication. During data transmission, each layer adds necessary header information through an encapsulation process to assist the receiver in correctly parsing the data. Additionally, network protocols include addressing mechanisms to include sender and receiver IP addresses in data packets, enabling precise data transmission. Moreover, to ensure data integrity, many protocols incorporate error detection and correction mechanisms, as well as flow control features to prevent network congestion and data loss, ensuring reliable and efficient communication. Next, we move on to the second part, common network protocols. The IP protocol, as the core of Internet communication, provides datagram services in a connectionless manner. It allows data to be transmitted independently without establishing persistent connections. Each packet adds destination and source IP addresses, along with other control information such as version number and protocol type, through an encapsulation process to ensure data routing from source to destination. While IP protocol itself does not guarantee data transmission reliability, it serves as the foundation for transport layer protocols like TCP and UDP, which ensure reliability over IP. TCP protocol, or Transmission Control Protocol, is a connection-oriented reliable transmission protocol. Before data transmission, it establishes a connection through a three-way handshake, SYN, SYN-ACK, ACK, and ensures data sequence and integrity through sequence numbers and acknowledgement responses during transmission. After transmission, it gracefully closes the connection with a four-way handshake, FIN, ACK, FIN, ACK. HTTP protocol, as Hypertext Transfer Protocol, is fundamental for web browsing. It defines communication rules between client browsers and web servers. For instance, when you enter a URL in a browser, the browser uses HTTP GET requests to fetch and parse HTML, then loads related resources to render the complete web page. HTTP protocol enables us to securely and efficiently retrieve and browse web page content from the internet. FTP protocol, or File Transfer Protocol, is an application layer protocol specifically designed for file transfer over networks. It allows efficient file transfer between local computers and remote servers, whether for downloading or uploading. For example, as a web designer, you use an FTP client with login credentials to connect to a server, browse, and upload design files to remote directories. The default port number for FTP protocol is 21. Telnet protocol, as a remote login protocol, allows network administrators or users to remotely access and control servers or other remote computers from their own computers. For example, a system administrator can use a Telnet client to input server information, authenticate themselves, and remotely log in to perform maintenance or monitoring tasks. SMTP protocol, or Simple Mail Transfer Protocol, is central to the email system, controlling the rules for sending and receiving emails. For instance, when you send an email, the SMTP server resolves addresses, locates the recipient's server via DNS, and securely sends the email to ensure accurate delivery. While SMTP is primarily used for sending emails, it can also work with POP3 or IMAP protocols to support email reception and downloading to users' local devices. POP3 protocol, or Post Office Protocol version 3, allows users to download emails from an internet mail server to their personal computer. For example, when setting up an email client account, you choose POP3 protocol to receive emails, enabling the client to download unread emails locally for offline reading. POP3 works in conjunction with SMTP protocol, handling email reception and sending respectively. DNS, or Domain Name System, is a critical internet service acting as a distributed database responsible for translating easy-to-remember domain names into computer-understandable IP addresses. For example, when you enter a website address in a browser, your computer queries DNS servers to resolve the domain name to an IP address, allowing the browser to establish a connection and access the website. This DNS resolution process is invisible to users but essential for network access. DHCP protocol, or Dynamic Host Configuration Protocol, is a network management protocol used to automatically allocate IP addresses and other network configuration parameters to devices in the network. For example, when a new device joins a wireless network, the DHCP server automatically assigns network configurations such as IP addresses and DNS information, simplifying setup and preventing address conflicts. IP addresses can be reclaimed and reused when devices disconnect, improving resource efficiency. ARP protocol maps IP addresses to physical addresses, while IRP protocol performs the reverse by mapping physical addresses to IP addresses. Both protocols play crucial roles in network communication. For example, within a LAN, computers use ARP protocol to broadcast queries for the MAC address of a target IP to send data directly, while IRP protocol provides reverse resolution, though it's largely supplanted by DHCP. ARP remains vital for network communication. Now, let's summarize the content of this lesson. In this session, we've learned about the basic concepts of network protocols and explored 10 common network protocols and their applications. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. This concludes the mini lecture today. Thank you, everyone.